Hello students, today we are going to discuss very important topic in hydrocarbon, that is preparation of alkane. Alkane generally it is called hydrocarbon, that is saturated hydrocarbon, alkane, and the carbon atom is hybridized by sp3 hybridization, tetrahedral shape. These are very common properties of alkane, that structure is tetrahedral structure, hybridization is sp3 hybridization, and these are also called paraffin. Alkane is also called paraffin. Paraffin because these are chemically inert, that's why these are called paraffin. We will discuss these things in chemical properties. So today we will discuss preparation of alkane. Alkane first preparation, we can do it, that first preparation of alkane from alkene and alkyne. From alkene and alkyne. Alkene and alkyne, that reaction is called Sabatier. It is also called as Sabatier and Senderens reaction. It is very important you remember this is as a name reaction. You also note down these things. Suppose you take ethene with hydrogen in presence of heating nickel, platinum as the catalyst. Temperature are around 600 degree Kelvin. Then alkene become alkane, ethene become ethane. Ethene become ethane. Similarly, you can take suppose CH3, C triple bond CH plus 2 molecule of hydrogen. Same condition on heating and nickel or palladium, platinum catalyst. As it has 3 carbon, produce propane. This is called propane. So propyne convert to propane. So this reaction is called hydrogenation or reduction of alkene and alkyne by hydrogen. So this is the one important preparation of alkene and alkyne. Second preparation, that is from haloalkane RX, from haloalkane. From haloalkane first you can write that Wurtz reaction. One main reaction write down, that is called Wurtz reaction. Here what happens? Any haloalkane reacts with sodium metal, 2 molecule of haloalkane presence of sodium metal and dry ether produce higher alkane. Produce alkane, higher alkane. So here 2 molecules required. That's why very important thing, remember, methane cannot be prepared because during the Wurtz reaction, as per the mechanism, mainly 2 molecules take part in the formation of alkane. That's why always higher member means odd number or even number of alkane will produce depends upon the haloalkane used. If haloalkane is pure, always even number. Alkane means even. Even number of carbon. Even number of carbon will be formed. Alkane having even number of carbon atoms. But if you take mixture of haloalkane, you will get odd and even number of carbon atoms in alkane. So this is called Wurtz reaction. Haloalkane reacts with sodium metal in presence of dry ether producing alkane. Then it can be also prepared from haloalkane by reduction method. Haloalkane by a reducing agent, any reducing agent, hydrogen, nickel, you can use producing RH, this product. Here one important thing is that what are the other reducing agent? Reducing agent can be used. Reducing agent can be used. That already I have told you, nickel and hydrogen, zinc and HCl, P4 and HI. P4 and HI also used as a reducing agent. Lithium, aluminium hydride can be used. Sodium borohydride can be used. These are some important reducing agent. It reduces haloalkane to alkane. This is alkane. So in this way you can prepare from aldehyde or ketone, aldehyde ketone, acid derivative, like this. It can be used for the preparation of alkane by reduction method. Method is reduction, same. If you take R2CO ketone, this is ketone undergo reductions using zinc amalgam and HCl. Product is RCH2R. Same number of carbon remains. There will be no increase or decrease of carbon. This reaction is called Clemmenson reduction. Clemmenson's reduction. That is one important name reaction, like your Woods reaction, Sabat-Sandrins reaction. This is the name reaction. Aldehyde or ketone, aldehyde also, same, zinc amalgam and HCl produce your 2 number. This is the alkane. So alkane is formed. So preparation, and from acid also you can prepare RCOH when undergo reductions. It can be used that P4 and HI. Product is RCH3. This is also alkane. This is your carboxylic acid. Carboxyls become alkane. So you have to see which type of carboxylic acid you are using and what will be the product of alkane. The number of carbon remaining same. Here R and C depends on R may be 1 carbon, 2 carbon, 3 carbon. So depends on the aldehyde ketone acid used, same number of carbon atom alkane will be formed. So this is very important, conversion of aldehyde ketone and acid to alkane. Then another important method, from acid also you can prepare from salt of acids. From salt of acid we can prepare alkane. One is decarboxylation. Decarboxylation. The name reaction is decarboxylation. Here what happens? You take any acids and use sodium salt. When heated in presence of soda lime, mixture of calcium oxide and sodium hydroxides produce alkane, corresponding alkane and sodium carbonate will form. So this is your alkane. This is alkane. You have to remember, when sodium salt of acid undergo decarboxylation in presence of soda lime, this is called soda lime, calcium oxide and sodium hydroxide, on heating produce alkane. Okay. Then second method also very important, that is Cole's electrolytic method. That is Cole's electrolytic method. In this method what happens? The same salt of acids in aqueous medium undergo electrolysis, then at anode alkane is formed, higher member alkane will be formed, then remaining carbon dioxide, and as sodium ion is formed, sodium atom on electrolysis will produce sodium hydroxide and hydrogen gas will form. So this is at anode, this is at anode, and this is at mainly cathode. Hydrogen produced at cathode and alkane produced at anode by the electrolysis of sodium salt of carboxylic acid, that is monocarboxylic, and forming what? Alkane. So this is called Cole's electrolysis method. This is called Cole's electrolysis method. Then another method, that cyclic compound can be converted to alkane. For example, you see the reactivity cycloalkane when heated in presence of hydrogen and platinum metal, it produces same number of alkane, having same number of alkane. Cyclopropane becomes propane. And here one important thing, the reactivity is cyclopropane greater than cyclobutane greater than cyclopentane greater than cyclohexane, but almost pentane, this pentane and hexane generally are very low reactive towards these reductions, because this is the depends on angular strain, more angular strain. In this case, angular strain is more angular strain, more is the instability. The stability is very less. That's so very reactive. Cyclopropane is more reactive than cyclobutane, pentane, hexane due to increasing what? Distance between the sides, different bonds. So here what happens? The bond here, this is 60 degree, so angular strain is more. This is the 60 degree, angular strain is more. This compound, if you see bigger form, angular strain is more, but this case angular strain is less. That's why this is less reactive. So any compound undergo cyclopropane also undergo reduction heating hydrogen and platinum, also convert to propane. Same. So two step it will be formed. First alkene become alkane, then the bond breaks and forming corresponding alkane. This is a very important preparation of alkane. Another important also selected reactions from Grignard's reagent, short form GR, Grignard's reagent, that is short form RMGX, that is called Grignard's reagent. Here this Grignard's reagent also produce alkane. First is by reductions RMGX, on reductions it also produce. Grignard's reagent reacts with water for producing RH. Same Grignard's reagent reacts with ammonia, produce alkane. You remember this way, reacts with alcohol, R-OH produce RH. It reacts with amine, also produce RH, R-NH2 produce RH. So Grignard's reagent GR, this is the Grignard's reagent, reacts with water, alcohol, amine, ammonia, forming alkane. Both cases produce alkane. So this is very, and some cases when Grignard's reagent reacts with haloalkane, R-X, Grignard's reagent reacts with haloalkane. it will produce higher alkane. How? You see the reaction. R dash will join, produce alkane, then side product is MgX2. This is also alkane. So from Grignard's reagent we can prepare alkane. From alicyclic compound also we can prepare alkane. From salt of carboxylation by 2 methods, decarbonization and Electrolytic methods. Reduction of aldehyde ketone acids also we can prepare alkane. From haloalkane we can prepare alkane by Wood's reaction method, or by reduction of haloalkane we can prepare. So these are some important methods of preparation of alkane. But methane can be prepared but directly by using carbides. If beryllium carbides B2C plus water produce beryllium hydroxides and methane will form. Similarly, aluminium carbide Al4 and C3 plus water, it reacts with generally hot water, it produces aluminium hydroxide and methane. This is only specific preparation of methane. Beryllium carbide water produce methane gas, aluminium carbide reacts with water, produce methane gas. Because beryllium, aluminium, we know diagonal relationship, both carbides produce alkane. So these are some important method of preparation of alkane. Now we'll discuss some important byproduct, some important product of Wood's reaction. Okay, you complete this one. Cl in presence of sodium metal, it will produce that is 2 cyclic compound will join. This type of product will form. Present sodium metals, here 2 will be joined. This is one application of Wood's reactions. Two halogen attachments. Here add this bond. This bond is weaker than this bond because it is larger side, this smaller side. So it will be considered. So the product will be this type of product also formed. So these are some application of Wood's reaction. So in competitive examination, different types of question may be asked related to the same concept, but some twisted type question will be asked. You have to think that what will be the actual product. Okay, thank you all.